lives and how we work. IFS.ai is industrial AI. It's the thread of intelligence flowing through your business in a world where data is everywhere and informs the lifeblood of your company. The thread that powers decisions made by humans or machines. The thread that revolutionizes your operations, optimizing your people, assets, and service. The thread that enables the world's most progressive organizations to contextualize intelligence, simulate outcomes, automate production, and drive innovation across your business at pace, safely. We're going beyond copilots. We're powering intelligent business. IFS.ai, industrial AI that enables your business to thrive and grow.
And tumble it, straight off the lot, 300 cash, and the car came with a blunt in it. Lil' mama a thot, and she got ass, that she gon' fuck up a bag. Pull up to the spot, living too fast, dropping the dip in the stash. In Italy, got too foreign hoes, they DM me. Draw at the top, when it's cold, but you feel the heat. Be real with me, keep it 100, just be real with me.
When a company takes care of its employees, employees always take care of the company in return. This company values honesty and always thinks from an employee's perspective. All the good things that we've done so far has been a suggestion from an employee. So one of the things that makes Calci a great place to work is we respect all our employees, irrespective of the designation. So if you take Danushka, who's our CTO, who has been with us from the inception, or else an intern who has just joined Calci, the ideas, opinions, suggestions would be given the same value. And I think that's one of the reasons why people always come back to Calci.
Wonder ekka be the wonder.
දවසම පිනවන වෙනම ලෝකයක්.
Recording in progress.
බණ්ඩාරගම ඩේවිඩ් පීරිස් සමුව්‍යාපාරයට අනුබද්ධ ආයතනයකි.
Stepped out of my zone.
Good evening, everyone. Welcome to Workshop 2 of CodeRally 6.0, Navigating the Unknown in Competitive Programming, proudly presented by the IEEE Computer Society Student Branch Chapter of IIT. I'm Ramiro De Silva. I'll be your moderator for today's session. We are thrilled to have you join us as we dive deep into the ever-evolving world of competitive coding. This workshop will explore how to approach unfamiliar changes using AI and solid programming fundamentals, while also understanding the risks involved when integrating AI tools into your workflow. Today's session will be conducted by Mr. Naveen Premaratna, Senior Data Scientist at IFS, who brings deep technical expertise and valuable experience in applying AI for real-world problem solving. If you have any questions along the way, don't hesitate to submit them by simply scanning the QR code displayed on your screen. We will address them during the live Q&A session, so don't miss the opportunity to gain valuable insights. Without further delay, let's welcome our speaker, Mr. Naveen Premaratna, to begin today's session.
Hi, I hope I am audible and visible also. Thanks, Ramiro and the organization committee. Hey, everyone. So, good evening, and it's a real pleasure to be here to speaking to you and going through this lecture. My name is Naveen. I'm a senior data scientist at IFS and a background in software engineering. I was here just like you, doing competitive programming, going into competitions and being undergraduates in the same way. And I'd say the LLM boom or the chatbot boom was somewhere around when we were finishing up the graduate years, undergraduate years. So yeah, I hope to like get you guys through some of the stuff that I have learned and I've been using in my workflows. At the same time, giving some insights on like why these things work and why we need to adapt, especially when it comes to utilizing AI in our day-to-day workflows. Um, I will share my screen. Someone give me a confirmation whether it's visible or not.
Yeah, it's visible.
Okay, right. So for the agenda, for the next, I guess, 60 to 90 minutes, we'll start with the big picture of AI's role in current day programming and dive deep into the art of prompting and explore some common traps and how to build your defenses for these traps. And finally, I would like to wrap up with some conclusions and demonstrations of what we can do with AI. So heads up, if you see anything wrong with the slides and if you see any misalignments in the slide, feel free to blame Gemini. And if the slides are good, feel free to praise him because these are generated through AI also. I was trying to cut some time there also in my workflow. So before we move on to some of the technical stuff, let's just take an abstract view. So why is every tech conversation these days starts or ends with the buzzword AI? So before we think about the benefits that comes from AI, let's be clear on one thing because everybody needs to understand still your brain or the human brain is the most powerful problem solving tool uh, around here so far, at least until advanced general AI would come into place. But even though the LLMs and the agents or the chatbots that we typically use, Gemini, it could be Gemini, it could be ChatGPT, it could be Claude, seems like they are very intelligent at what they are telling us when we prompt them. It's inherently an pattern matching machine that predicts the next tokens. So even with the thinking models, it's just a back and forth conversation inside the model that gives you the illusion that it's going through a deep thinking process. It works very, very well, but uh, you have to understand the technicalities behind that and not to be like sort of mystified by the illusion that it's showing. So why am I saying your brain is the most powerful tool still? Because you can still understand uh, business requirements or nitty gritty details that's behind the scenes. You can reason about abstract concepts and apply them into novel situations. And you see it in a completely different way to what we provide LLMs and what the way that we provide context to LLMs, which comes to the next point. You understand unwritten rules and you are the one that understand the goals that you're trying to tackle. And it is very important when it comes to working with real world implications. And the best part that I would say is in humankind's defense, we are yet the best creative and intuitive uh, uh, brains compared to some models. But maybe I'll be challenged next week on this. Maybe they'll release something that's far exceeds human brains, but if we think about in like abstract way or like logical way, uh, your brain can is the only thing that can like truly generate new algorithms or come up with creative solutions that didn't exist in previous patterns because whatever LLMs are doing, it's doing on previous trained data and what it has access to. Now, with that, I would come to the advantages we get with AI. The main thing is the knowledge that it has access to. These models are trained on a staggering amount of data. This could be documentations, books, and virtually the entire public internet's worth of code is available to it. the LLMs. It's like having every textbook, Stack Overflow post instantly accessible in a conversational partner. So we can't like undermine that value. And the next thing is the speed at which it can generate code, test hypotheses, or summarize documentations. So we can't compete with that even in the current, even when we compare to the current LLM models. So we could treat it as not a replacement of your intellect, but at least at the current moment, it will be an amplifier if you properly use it. And I'd like to address this before anyone asks it, or because I know everyone might have thought about this at some point. Uh, so the big scary question, will AI take our jobs? So if we take a look through the history, it shows us that major technological shifts don't usually eliminate fields itself. They usually transform them. So when high-level compilers were invented, they didn't like get rid of all the programmers, right? They got rid of the need to manually write assembly or machine code. So they raised the level of abstraction, and programmers who adapted became more powerful and more relevant to that day and age. So this is the same situation, I would say, and I would say it transcends beyond time, adaptability. Starting at a problem that feels completely foreign. So this is what I would call a hidden trap, because your first instinct might be to ask the AI just solve it for you. So I suggest heavily against this. Don't, because in any problem solving scenario, even though you could like drop the whole specification into maybe let's say Gemini or ChatGPT and get the code back from this LLM or this chatbot, you yourself has no idea what's going on in that code, right? And not even the code level, you wouldn't have an idea on like what the problem even was. So one question is like a ethical question: why would you do that if you want to like learn and improve yourselves? Because you are not improving if you are copying something and putting it there. And the second question would be, what if AI got something wrong? So there's a lot of intricacies in that department these days, especially with like how advanced the current LLMs are, because most of them it can rival like a basic programmer's knowledge on some aspects, but not always. So in a scenario like this, when you have zero understanding, my suggestion is to get your understanding up to a level that you partially, at least partially, know what's going on behind the scenes and what you need to do in this space or this project that you're working on. So the first goal is not to get the answer. The first goal is to build your own understanding. Use the AI as a tutor instead of asking, write the code for this, write the code for this. You should be asking like questions like what I have shown in this slide. So if we go into like an example, let's say you are a student who has been told to use Dijkstra's algorithm for a problem, and but you have no idea what it is, and you haven't gotten like any material to learn about this. You are just asked to learn about it, self-learn about it, and implement it in some way. So I have shown you like a simple breakdown on how we could like tackle this. I'll go ahead and show you a few prompts that we can do here, like on the live session. Hope this screen is also visible to you guys. Can someone confirm? Should be a good screen. Hello?
Yeah. Yes.
Okay, thanks. All right. So we'll take the same problem. So you have to use Dijkstra's algorithm, and you have no idea what it is. So you don't even know that it's a pathfinding algorithm. So let's say we are in the same boat as this hypothetical situation. We'll just ask that something like this. We are asking to explain it in simple terms. Maybe add in a pointer So my bad. So looking at the screen, explaining it to a first year student. So let's say this is what you are going to write. So the last part, it is when you're doing like prompting, and this is like basic prompting skills, like not even like deep prompt engineering stuff. It is always better to provide as much context as possible. So in this case, we are saying that what level of information that we need here. So if you had a different scenario, you might be wanting to use something different. Maybe you want to like deep dive into the extract algorithm. You want to like understand it in like a graduate level. So it is better to always like provide the context or the level of understanding that you need when you're like trying to probe information from an LLM. So you can see the AI will give like a high level overview, explain that it's an algorithm for finding the shortest path. Let's say it has shown that, and also it's kind of given a pseudocode, but not a pseudocode. It's like a step-by-step recipe to do this. So let's say you have gone through this. Now you have some idea of like what we are going to do with this algorithm, right? Now, we need to get a breakdown of this just to try to understand like a bit of nitty-gritty details of how we are going to do this, because currently, while we know what it's going to do, we don't know how to do it. And we are not going to jump into whatever the coursework or the problem that you have to solve in a competition or something. We just need a bit of more information on this. So I'm just going to copy paste the prompt that I prepared. So here, I'm telling the AI to break down the main steps of the extract algorithm into pseudocode or a numbered list. So it has given the numbered list here, but I hope it'll provide pseudocode. So yeah, now that's a live scenario that you show. I sort of like messed up there by not only mentioning the pseudocode part. So we can probe. Something simple would work as long as you are like conveying the proper intent, what you need. I guess it wouldn't like go beyond this. So if we want to like now understand it in like a language level, I guess pretty much this step-by-step guide will be the pseudocode itself. So we can treat it like the pseudocode. Now, let's say you have an idea on like how this algorithm works, but you don't know how to implement it. So now a good suggestion is to build up an idea on like from the implementation side. So always start from the theory side and like trying to get at least an foundational understanding of what's going on in the scenes on a certain problem. But when you want to properly understand it, try to go into the implementation side and get a code or build that you can play around with. Because in any scenario or any system, it's always better to like tinker with it and try to understand it. So the next step would be to like give me a sample code in Python with the worked example on a graph with, let's say, 4 nodes. So this would result in us getting hopefully a Python code. And now you have something you can run and manipulate the inputs and outputs and slowly understand what's going on there before you can move on to the next stage. So I'd say if you were to properly do this on a problem like where you don't have an understanding on, you can cut down on the time that you need to like put in to learn it and move ahead with the problem. So with that, let's say you got a partial understanding. Even though I'm saying this here, we'll end it with some Python code at the end just to understand the implementation level details. So at that point, I'd say you have a partial understanding on a problem, and we just assume that we are at that point. So what to do now? So you know what it is, but not the complete concept of how you can do a certain thing. Now you could shift your role from a student of the AI before to a sort of a project manager or program manager that has the AI as a junior developer at hand for you to help with. So you know the high level guidance or the context that needs to be given, and the AI knows how to implement it at a granular level. So it's going to be a back and forth conversational process when you have a partial understanding. So you're trying to connect your existence at the same time. At the end of the process, the best case scenario would be you'll have a much more deep understanding on the subject. At the same time, whatever you are trying to get done will be finished. So you can read through the example prompts shown here. But if you take an proper example, so let's say you know you want to get some data through an API, and you know what Python library you are going to use, but you don't know the syntax or the implementation level. So what would you do? So in a situation like this, you can use a simple prompt like this, but explain what components or what framework or what library that you're going to use, because you have an understanding of that part. It's just you don't know how to do, right? So your goal is not to like just get it done. Your goal is you need to try to understand while doing this process. Now, I think my connection is a bit slow, but we can proceed with it. So let's say this is the code that you got from the prompt. Now you know, no, initially you'd get something like this, let's say here. So you haven't told about anything like specific error handling or what to do with the edge cases or something like that. So it has given what you asked for pretty much. So it would work for the happy path, but you have the partial knowledge to tell that you need to handle errors here because you know the APIs work in this way. It would give these errors, and we need to expect them. We need to catch them. So that's where the partial knowledge that you have would come in handy, because if you are like a completely new person to this domain, you wouldn't have an idea. You are going to expect that this is going to work for all the cases and all the scales. So that's where any amount of knowledge that you build up would come handy. So let's tell the AI you need to handle some kind of exceptions and get it done. So, oh, that's fine. I guess we can work with the pre-set up stuff here. So yeah, so ideally that would give you a code like this where you have the exception handling in place. Now, let's go into a scenario where you have the proper knowledge or you can be called an expert. So there's a little caveat here. So you shouldn't like at any point in my opinion treat yourself as a complete 100% expert on a certain thing, because you know as you learn there's a lot more to be learned. Like it's never going to end. So but at the same time, you at a certain level you know about a certain topic that you can manipulate stuff in that area or like in that project uh, with proper understanding of what's going behind like the granular level. So in a scenario like this, we could tell that now you are not just the program manager or the role that I have mentioned previously, but you are sort of like the architect in your own project, and the AI can be treated as like hyper efficient, let's say, construction crew or like engineering crew that you have access to. So this is where like prompts similar to like refactoring, maybe like unit testing, and even also like new implementations into the architecture would come in. With your proper understanding, you are the one that's reviewing all the changes, and nothing should get through you without you understanding what it's going to do. So let's get here. So imagine a scenario like this where you are trying to like, let's say, it's an example. So can we take? So let's say take this example first. So here, what's the goal? So you have written a correct Python function, but you know what it does inside and out, but you want to make it better and document it faster. So this is a working function which you need to make a bit more efficient. So I'll try to maybe utilize Gemini here since Copilot is not cooperating now. I'll try to do this. So here, you know that the code is working and you know what kind of refactor you need and you know how to review it. So something like this would be a perfect prompt here. So let's say refactor this Python function to be more Pythonic and concise. We are trying to like pretty much get it to a single liner. So let's say possibly use single list comprehension. Yeah. So we got pretty much what we wanted. So, and we knew what we were going to get. That's the difference between the two states. Because in the previous levels of prompting, you are like waiting for magic to happen. And here you just know what's going to probably pop up. And if something different comes up, you intuitively know that this is not what I need here. So I need to like maybe play around with the AI, go and back and forth conversation with the AI to like change the structure of what the changes are being doing here. So let's say we accept it. Now we need to generate a doc string. Let's say that's also a scenario that you heavily use. Like in this level of context, you are just automating stuff. You are trying to make things more efficient. You are not trying to like try to understand how to do changes. You know how to do changes. You are just automating it. So that's the perfect level of understanding you need to strive for in order to like make everything much more efficient. So all this to say, even though it looks like you can build anything with AI, like with a single prompt these days, you can understand with the proper fundamental knowledge on whatever the field that you're working on, or whatever the project that you're working on, combine it with the understanding on like how to properly utilize AI in different scenarios, you can get far more efficient. Because if you were to build the same thing with zero understanding, you're going to run into issues one way or another. Because even though the current LLMs and AI models are sufficient in like building up really complex programs, it is your understanding of how to prompt and how to provide the context that would bottleneck the process, at least in nowadays. Because Gemini 2.5 Pro or like Claude models, the recent Claude models, even the ChatGPT models that we are using, are complex enough to like handle, let's say, even writing the production grade software. It can be done if you are meticulous enough and you know what you're doing. But if not, it's not a good idea to build something. You might have heard the stories of like people starting startups and creating web services like really fast, and they create it fast, they grow fast, and they fail fast. So you need to find a fine balance between these scenarios. And with that, let's say, what are the pitfalls when we run into when working with AI? So as I explained before, AI can fail, but at the same time, uh, it is much less prone to failures nowadays than it used to be. So like, let's say we compare to like the first chat GPT models, these issues that I have shown in the screen, like hallucinations or training data biases, would be much more prominent in those models than the currently available like state-of-the-art models that we have. So it's a good thing But at the same time, this has become to the same problem that software engineering previously also had. So there's a saying that if the computer is doing something wrong and something unexpected, it's most probably not its fault, because it's usually like, let's say, regardless, put aside AI, a computer is following the exact instructions provided by the user or the developer or the programmer to it without missing any steps. Unless, let's say, like, I can't remember the name of the phenomena. Whatever the rays that's coming from the space is going to change bits, like something, unless something like that happens, it's not going to do any mistakes. It's just going to carry out the steps that you provided. It wasn't the case in the first stages of like LLMs, but now it has come to a point, it's almost the case. So 95% of the time, it has become the developer's fault that it didn't provide the enough context. I'm not saying this is like a 100% thing, because I can give an example like where an LLM might fail. This is something that you run into in the industry all the time, because when it comes to university projects, or let's say like normal hackathons or competitions, we are used to like using languages and frameworks that is very familiar to people and very popular. So the moment you run into something niche, a framework or something new, a language, that's where the problems would start coming, because the LLMs wouldn't have like previous data. And in the same way that the edge without LLMs, what we did when a new language comes in, when a new framework comes in, there's no information on the internet also. Like, people are starting to use it and people are trying to adapt it, and there's no information already available. So that's where your brain comes in. And even there, we can take advantage of AI when it comes to learning, because uh, I think I'll get to that in a later section, because that would suit better. But just keep in mind, things are changing, but the patterns keep emerging. So if we want to adapt, as I mentioned before, we can study the patterns that the previous technological advancements has shown us, and try to use them. And they are probably going to work, as I mentioned. It's most likely to work in these cases also. So when it comes to these problems, so hallucinations. So an LLM's goal is to generate just a sequence of the next tokens that is statistically probable. And we can't say these are like factually correct at all. It has, if it has seen many examples where a certain library has certain types of functions, it might invent a function name that sounds plausible but doesn't exist. So it's just trying to complete a pattern, nothing more. And when it comes to training data, the model reflects its training data. You might have seen this if you have closely worked with like different LLM models, even other machine learning models. You do know there's a bias if you don't handle it properly. And the bias we can't take away 100% also. So it's going to be there. As an example, I can say this term some of you might have heard, the embedding models that we use in order to like create embeddings for text or the strings when we use it against LLMs, or to create vector data out of strings. These embedding models are primarily trained on markdown data. Like, if we take the data sets that is used to train these models, it's a vast amount of markdown data. So there's an affinity for these embedding models to work better with markdown. So that's an example I can give from the industry side. So that's where the place that the training database would come in. But at the same time, I could explain it in a way like this. So let's say uh, there are software engineering best practices, but we can't say the best practices are always the ones that mostly followed, because that would be a false statement. There are a lot of bad practices or non-optimal practices that has become the norm, and people maybe like ignore it, but it has become the norm. So if you take a look at the vast amount of information in the internet, and these LLMs are trained on most of those data, you can already see it's going to expect that wrongfully standard pattern, which has become the standard pattern because like people have mistook that for like the proper pattern to use now, but the LLM will suggest it as the hard truth when you're asking a question about this topic. So it's not like a magical thing. It's something that naturally happens, and it always has happened previously, because like even in the age of where you are going to like use Stack Overflow to like debug something, uh, if most people are following the bad practice, you are eventually going to follow it unless you go into like the granular levels and understand, okay, there's something wrong going on here. So that's one thing. And the next thing is the lack of causal reasoning that these models would have. So even though it looks like the AI understand that when you write the code line x equals x plus 1, you think the AI would like understand that this is going to increment and change x. But realistically, it just knows that these tokens often appear in this order, like usually. And this shallow understanding means it can't like reason about real world implications or logical consequences after a certain point, especially if there is not enough data, and even if especially when it's like a very niche. So I think some of you might like were hobbies developers that like try to do niche things or like use niche frameworks might have run into this issue. But I highly encourage you to like try out something niche like that, maybe like a very like the latest new upcoming language, and find something that doesn't have much documentation or work around it, and try to utilize the AI in the same way. I guess it would be like a really good training exercise for everyone to like see how we can adapt to those situations. So with that, with all of that said, I have to say it was really hard to find like a common pitfall to put this AI in, especially when we are like properly prompting. Most of the time, it is picking up on intricate details or like smaller stuff. So mostly nowadays, as I mentioned, if the AI is like doing something wrong, you probably didn't give it enough context. So like in a scenario like this, so in this prompt, it's saying I have a list of product IDs, write a Python function to sort them in the ascending order. I don't, let me check the time so it can balance it out. Yeah, I'll just go through the explanation of this rather than trying to like do the live demo, but you'll get the gist of it. So with this prompt, you can understand that it's probably not going to like care about what kind of IDs there are. So when it's mentioned as product IDs, let's say the AI expects it to be integers. But as I have shown here, if we provide it as a string value, now it's if we want to get it sorted, what was in your mind was to sort this in like prod 2, prod 11, and prod 100, right? But that's not going to happen because it's going to do a string sorting and it's going to return the wrong order there. So that's a scenario where you would have to like bypass that with something like I have the list of product IDs with the numeric part, and maybe give a bit more information also, something like this, how the value is formed. So if you do it that way, you can see that it's going to do a better pattern matching using maybe regular expressions. Yeah, it has used regular expressions. So that's one place. And take another example. Yeah, you can see this is what I meant. So I didn't like touch upon like creating these slides that much. So Gemini should take the responsibility there. But that's a good point. I should have taken the responsibility, as I would say to you also, because AI is just doing what we ask for, and we are the ones accepting the changes. So the concurrency trap, I wouldn't say like I have just put a fancy word there, but it's not something big. So let's say a prompt like this, I'm using Python with Flask or something like that. So I'll show you the rest of this prompt that I was trying to do here. Right. Let's say it's like something like this. We can try it with Gemini because I'm not sure how well it would work, but let's try it. So here I'm saying I'll paste. So I'll accept this and I'll paste the prompt here so you guys can see it. Let's add a comment. Okay, I'm using Python with Flask for a small web app. I need a basic counter to track API hits, show me how to set up a global variable and a simple endpoint that increments it every time it's accessed. So if you look at it at the first glance, it should work. Like it definitely should work. Uh, uh, so can like any of you think what's wrong here, like in like an API standpoint? So it's not the LLM's fault because we have mentioned that we need a small web app. But even for a small web app, let's say we were going to like have multiple users and there are possibly concurrent scenarios that's going to happen. We are eventually like going to run into an issue where two users hit the same endpoint at the exact same millisecond, and the counter operation here is not an atomic operation. So it's going to be actually 3 steps. So read the current value of counter, add 1 to it, write the new value back. So one hit will be lost forever. So that's a race condition, textbook race condition. So we could have avoided this if we understood that we are going to encounter this and we need to provide that context to the LLM. So simply if I say something like refactor this so it can work in a thread safe multi-threaded production server. I hope that this might be enough for you to pick it up. Yeah, you can see threading.lock has been implemented. So as you can see, these small mistakes can be avoided if you understand the scale of the project that you're working on and if you understand how to properly give that context. Even though if you don't have like Python level implementation knowledge on like threading and how these libraries work, if you have the fundamental knowledge of like how concurrency works, then you could like work with the AI to figure out how we can do it with the Python code. So even here, if you get this code and you accept it, and you don't understand like what this trading.log would do, I mean like even the simplest way still works. So you can go into this method and read it at any time. It's never going to go away. Like if you like enjoy reading like the underlying library code and everything, it becomes asset for you anyways. But at the same time, you can utilize the LLM to like try to get to understand what's going on behind the scenes in those methods, right? So yeah, and that's the concurrency part. This is a similar issue, so I'm not going to like go too deep into it. So this is somewhere that we ask for a certain change without giving the proper context of where things might fail. So you can see it has utilized this method, but at the same time, it doesn't consider that we are going to hit an API rate limit. And any good API call should have proper fallback plans and proper retry mechanisms in place with a definitive bounce state. So that's something that if you like don't have an understanding of that, probably the AI is not going to put that much level of detail into that. But that's where providing better context helps you with, because even in this previous scenario, if we have mentioned that this is something that going to accept concurrent users and it's going to run in like a multi-threaded platform, then it would have like given the first response with that information. Like it would have given the first response with the locking place. So you can understand providing the context always matters, even though you don't have an understanding on what's going on. AI is competent enough this test to like provide you with the suggestion. There's something wrong here, you need to address this. So I have added the lock here. So that's something you would encounter if you provide proper context. it will tell you, okay, if it's like a web server with this much of users, you probably should think about multi-threading and concurrent programming. So yeah, that's one thing. Yeah. Next up, let's say, let me check the demos. I did the 3 demos there. And let's say, yes, did I cover that part? Bear with me for a moment. Yes. Okay. So how do you get the fundamental understanding that I previously talked about? So I have told you like to get like library level understanding, maybe language level understanding. So how do you get the language agnostic, library agnostic, and framework agnostic understanding of software engineering? It's pretty much the exact fundamentals that you learn in the undergraduate years. And I know we might consider those things like maybe a hindrance when we learn them and when we are facing exams, assignments with them. But at the same time, those are the core things that build software, and those are the core pillars that we need to understand properly in order to evaluate a piece of software. So as I mentioned, yes, these are just a few pointers, but the fundamentals of software engineering like goes far beyond this. So if we take like algorithmic time complexity, that's a very major thing, especially when it comes to like competitive programming. You need to understand like how different algorithms perform and how different logic patterns perform when it comes to the complexity. And take it a step further, I would say from our data science field, we are constantly measuring efficiency with experiments also, because we wouldn't just rely on like the big connotation and the time complexity. We carry out experiments based on real data to validate those hypotheses. And the data structures, algorithms, data structures would help you to like spot places where certain unoptimized access to data is there. And data structures is something that would be crucial for any field, subfield of software engineering, be it like data science, data engineering, uh, web applications, server-side applications. It could be networking, cybersecurity, anywhere you go. The core of software and how it works would be data and the flow. So one core part is data. You need to understand how it can be structured and how it can be handled in the most efficient way, depending on the scenario. And algorithms, it's a given, right? So it's not just like it's not just like knowing thousands of algorithms to do certain things. It's the base level understanding of like how to build an algorithm. I would compare it to like sort of memorizing a derivation of a certain formula and compare it with like understanding how it's derived uh, in place whenever you need. So you can understand the difference between that knowledge. That's the same with algorithms. If you memorize algorithm and how it's doing something, probably you will be efficient in, especially like say hackathons or competitions. I'd say it's partially memory. It's a good thing to have like a toolbox of algorithms at your disposal. But at the same time, if you go to something like a optimization problem, or like let's say like 24-hour optimization hackathon or something like, so it's not going to be same all over the place, even within the competitions. There are places where you need to be the person who creates the new algorithm. So you need, even if you like learn 100 algorithms, I'd uh, sort of guide you to learn 10 by heart on like how it is broken down and how it was built up. So you have the flexibility to even manipulate that algorithm and create variations of it. That's the level you should strive for when you want to like understand algorithms. And this is in green, but it should be in red. Never ever commit code that you do not fully understand. You are the one that should own the code that is committed into a certain code base. Your name will be in that commit. It's not the AI that's going to be responsible for that. It's you and the code reviewer. That's the only responsible person for a certain commit or PR merge. So keep that in mind. With that, what's the mindset you should have? Uh, you shouldn't just be a coder or a programmer. You need to be a strategic problem solver. Before you learn code, before you learn programming, you need to be a problem solver. You need to understand it in a code agnostic way. So programming languages or code is just a way for us to like convey information to the computers, let's say, to the machines. And it has evolved from bits, ones and zeros, to the place that we are with Python and other languages nowadays. But at the same time, whichever language you use, whichever framework you use, it's just a matter of like conveying the idea or the problem solving pattern that you have in your head. So I always say this, there weren't like software engineers that came out of the blue. There were electrical engineers, there were mathematicians, there were physicists even, and mechanical engineers that learned code and created programming in order to resolve problems. So software engineering is a thing that came out of those fields. So what do all of these people have in common? They are very good problem solvers and they are very good at what they're doing in that context. They try to understand an issue and they just try to resolve an issue with the tool set that they have, and they widen the tool set if they can't do it with their current skill set. So coming back to AI, AI is your collaborator, it's not your replacement. That should be your mindset. Use it to amplify your skills, not to like uh, think low of yourself, think high of yourself, and be the one that can manipulate AI and use AI to the highest extent. And your fundamentals, as I mentioned, will be your shield and your guide throughout the journey. Uh, People are saying, I'm not going to like point out, but people are going to say fundamentals might become less important in the future, but I see it as more important than ever in this day and age. It's, as always, it's the thing that's going to like uh, make you stand out from the crowd at the end of the day, because anyone could utilize AI, but not everyone can manipulate it in a way that's almost seems like magic when it comes to like what we can do and the efficiency we can bring to the table. And the next thing is master the art of prompting. This is something that's kind of new, but I wouldn't say it's a completely novel thing. You can like sort of combine this with like early practices that we had in a way, because pair programming was always a thing. And a good pair programmer or good team worker always knew how to convey information, because this is a crucial skill that you can sort of pivot from field to field. So let's say one thing is telling AI what you want to do, but when you're doing work with a team, especially in the industry, you need to understand how to provide the proper context before you are pitching a problem or thinking of a thing that you want to discuss with a group of people. And even with on a one-on-one session, on a pair programming session, this is a very valuable skill, because you need to bring everyone to the same page before starting work, right? So that's why I said like these things, people make it seem like these are really new things that came out of the blue, but these all of these are like eventual progressions of systems that we already had. We just need to like properly understand the progression and jump on it. And always be skeptical up to a point. Never trust, always verify. Test for edge cases and question the logic yourself. Create unit test yourself if you need, to make sure that everything is smooth and clean. At the end of the day, as I mentioned, it's your name that's going to be in the commit. So by embracing this mindset, you'll be faster, sharper, and better equipped to solve the complex problems of tomorrow. I do have some extra demonstrations that I prepared, but I'll go through this without the actual live demonstrations. I just want you guys to have this as like a sort of hints or tips that you could use in your undergraduate years, maybe in like when you come to the industry. So this is a case that I have mentioned here. I'll go through the scenario. So let's imagine like you are in a hackathon project and you need to like send SMS confirmation to users on a certain prompt. So we decide. Let's imagine we decided to use like an API called Filio, but we have never used it before. Maybe the organizers sort of enforce the rule that we need to use it. So or how would have we done like this before AI? So pretty much we have to like refer to documentation. We have to go page by page, find where we need to like find which sections that we need to read. Excuse me. And we need to filter out what the information that we need to take from that documentation. So it was a hefty process, and people adapted it back in the day, and that's the only way you could like be a real fast learner. Nowadays you could utilize AI to concatenate all that information and give it as context. Maybe the documentation give that as context. And uh, as I have mentioned before, this is not something new. Try to migrate existing processes into AI workflow, because if you break it down, the process that you take to like learn from documentation is you have a certain set of problems, you have a certain set of context that you need to work on here, and with that in mind, you go read through the what's available in the documentation, and you try to filter out the information that is relevant for this case and relevant for your problem. So the components or the variables are the same. So you just have to provide that to the AI to ease out the filtering part and get the most efficient information retrieval in that sense. So I'd say on the abstract level, that's something I would say. I could have gone on like show how this could be done in like a live demo, but for the sake of time, I'll stop there, and you can maybe experiment with that on a project in the future. Yeah, the next thing is debugging. This is anyone would run into debugging scenarios eventually, and I'd simply say the worst way you can like debug a problem with AI is to copy the error, paste it in the AI chat prompt, and copy and paste whatever the code that it provides back into your code base and run it. And maybe it works one time and you are going to commit it. Now you have no idea what went wrong and how it was fixed. So in this case also, I emphasize the point, give the context, give as much context as possible, give what kind of data that went, like what kind of data was used in the scenario that went wrong, and what you have in mind as like hypothesis or your suspicions on why this wouldn't work. Get all of that and put it in as a context so that the AI can help you better. Just don't get in the habit of like copying out the error and paste it in the chat box, because previously that's what you had to do. At least you have to start from somewhere and do a Google search and read through heaps of Stack Overflow chats. There's going to be like very informative stuff, pieces of information in the chat, and the rest will be like two people barking at each other on like what framework is better and what architecture is better in that scenario. So you are given a godsend tool to filter out that noise, and so I would just give the simple advice: use it properly to make your workflows better. And this is something even simpler. I wouldn't even have to go deep into this. With AI, let's say you are running into a scenario where in a hackathon you have to build a quick web app, and it's going to be a very limited time that you have, and you are not going to worry about the scaffolding, like building the scaffolding, because that would take the precious time that you can use to think about far major components, user experience, be it security, be it robustness, be it more features. So make the AI give the proper context as again, make the AI build the scaffolding, but let I do it under your supervision. So you know how the scaffolding is placed and you know how the boilerplate code is placed. So you can manipulate it when you add in more information or you add in more features into that code base. Uh, yeah, before I end it, I'd like to share two interesting memes that I found. So this one says, "You won't lose your job to a tractor, but to a horse who learns how to drive a tractor." It's a bit cheesy, but at the same time, it has some amount of truth to it, because it's the adapters that adapt to the new technology and be the ones driving that technology would be relevant when it comes to like an evolving field. So this is very true in a sense. And the next one is, uh, so I'll go through this. So when it comes to like waterfall development, you have an idea on like you're going to build this car, and any step that you take is to create that car piece by piece. So there's a very structured approach there that you take. Usually you use this when you know the process, like you know the end-to-end process uh, without much dynamic or variability added to that. And in agile, you just build something that can get from point A to B, then you slowly build upon it like with new features, with new feature requests. So you make it a scooter, you make it a bicycle, you make it a motorcycle, then you come to the car. With AI, I'm before we go on to the vibe coding thing, with AI, usually you are given like a super high level space uh, car, which has features that is not even useful, most of the time gimmicks. So you create something that has more features than you need and cut down on it. This usually happens even if you are very careful with the prompts. As most of the time, over engineering is going to happen by nature with AI. And the vibe coding thing, there's like a controversial topic. Vibe coding is a controversial topic mainly because it's like an ambiguous term at the moment. Like it's not something that's properly defined, at least to my knowledge. But uh, power to you if you know how to do it properly. But if you are like just going with the vibe and not even like checking what's going on, it's probably going to be like a car piled up with junk. So at the end of the day, you can see uh, you are not going to recognize what you have built. AI is not going to figure out what you have built. And God forbid, like whoever reads this code is definitely not going to figure out what you have built. So that's the thing with vibe coding, especially if you are actually vibing and just letting the AI do the thing without properly reviewing. With that, I think I have come to the end of what I wanted to share with you. Thank you so much for your time and attention. And I hope this has been a valuable input to your journey and in these competitions and beyond. And I'd happy to answer any questions you might have. Ramiro, can you
Yeah,
point
we'll be
me
sharing the
to?
questions soon.
Yeah, sounds good.
Okay. So thank you very much, Mr. Naveen, for conducting such an insightful session on using AI effectively in problem solving and how to remain grounded in core fundamentals. And now it's time for our interactive Q&A session. We received some fantastic questions from you all, and our speaker is here to share his insights. Let's get started. We will share the questions. You can go ahead and answer them, Mr. Naveen.
Sure.
The questions are shared on the screen. You can go one by one, Mr. Naveen.
I'm not seeing the screen share. Let me check. Yep, I can see it now.
Okay.
Okay, I'll start from the left, I guess. I think that's the timely order. So get data science internships. What kind of projects we should do? That's a very common but a valuable question for people who are seeking like internships and jobs in the field. Uh, I'd say with the industrial space and the job market being as competitive as it has ever been, everyone values ingenuity and critical thinking and sort of like beyond qualifications, sort of the way that you can think and solve creative problems. So this can be different depending on like who's hiring because it's not a constant because depending on the role maybe it would need like a very high level understanding of theoretical concepts, or some roles would need uh, a bit out of the box thinking. So it would be a dynamic space. But to get a best of both worlds balance between this, I would say uh, work hard on your fundamentals in the university and those assignments that is given on those spaces, and try to do those assignments to learn beyond what's needed for the exams or just to do the assignments, because at the end of the day if you make it a enjoyable learning experience, it's going to benefit you, like it's going to be like a win-win situation for you. At the same time, there are these like integrate passion ideas that comes to your mind, like what if I build something like this, can I do this with AI? So these kind of questions, don't brush them off. Do research on those and find projects that have been built similarly and try to experiment yourself on those projects. uh, it might fail because it's pretty hard to like understand machine learning like in general at first. You can create models very easily, but it's very hard to understand the processes behind that. So it's a it's a pitfall where you might like get a wrong understanding that you know stuff but you are not 100% sure on those. So it's sort of like something you have to be careful of. But at the same time, if you try those ideas and try to bring those ideas into tangible projects, even if the outcome fails, the learning experience is so valuable that most companies or most people that's looking to hire will value that. So the best part is do those projects, document them, create blogs if you want, create video logs on those projects if you want, create presentations on those projects if you want. Just follow those passionate ideas, don't let them brush off. Those are the things that make you unique, because even if you do like a capstone project or something that's at the end of let's say a guided tutorial or guided course, that uniqueness you would bring with something of your own, and if you do it by heart, trying to understand the intricate details of the theory behind that, it's going to make you stand out. Yeah, I hope that gives a proper answer to your question. And for the next one, so from my POV, we need to use AI to break the limitations of human knowledge. Am I right, sir? Human knowledge. I would say, yeah, that's a correct argument. Uh, but it's again, it's not like something unique with AI. I think this mindset has been lost throughout the years because like inventors on the like first industrial age, or let's say when electricity first uh, was used by humans, and let's say like when the first computers was found, let's even say like Alan Turing creating the machine to break the Enigma code. Those places, people were pushing to break the barriers of human knowledge and understanding it's done in any space. So I'd say as humans, which have like a far higher intellectual capacity when it comes to like compared to all these species on Earth, it's sort of like our natural tendency to go to that lens to break the limits of our knowledge and our current understanding of certain components. So be it AI, be it the next tool that comes, uh, if that's your passion to seek the edges of the human knowledge, uh, you're going to be a good researcher. So I'd say it's a good thing to focus on if you're passionate about it. But uh, it's a hard field, I would say, because it's only the most passionate people uh, that thrive in those spaces. Because uh, going into the unknown, even with like tools like AI, most of the time, if you go into the unknown without with even AI as a companion, you are still in the dark because unknown is the unknown. AI feels the same way on that one. Uh, yeah, that was all around the place, but all over the place. But I hope that gives some answer to your question. And if I don't understand anything in the problem statement, like literally nothing, how should I even start using AI? Okay, this is a sort of a place where I was mentioning the zero knowledge scenario that you have on a certain use case or context. Mm, I'd say try to leverage AI as much as possible to try and get it to like teach you the underlying context for the components. But if it's something that the current models probably can't teach you or get you like give you a kickstart on like start looking into this, I think that's something that might something like that might be in like very niche field or like a niche subfield, something of the kind that I have mentioned about like going into the unknown. So if you run into that kind of a thing, it's always makes sense to like reach out to your peers, reach out to your mentors, reach out to the experts in the industry to get an idea. But most of the time, you can get an understanding on something by trying to work with AI. And if that's not enough, there's always this going back to our previous methods. We can search through the internet. Books are something that people like really avoid these days for some reason, but has a, a mountain of knowledge in those. So books, the internet tutorials, uh, educational videos in the net courses, these things you can still refer to these. It's not, those are not obsolete. People are still teaching in universities, so those are not going to go away anytime soon. And at the end of the day, it's the knowledge that you gather that matters, not the way that how like not the medium that you got it through. So it's up to you to like filter out what's good and take that into your knowledge base. Hope that was a helpful answer. Next one, sometimes I get like half the idea, but not fully. Those cases, how do I frame a good prompt to AI? I think I sort of went through this in the partial understanding section of the idea, but not fully. Keep your goal in place to make sure that you are trying to get the full idea anyways. So that's one thing I would add to the previous answer. And I think most of the stuff that I have mentioned in the partial understanding section and the previous answer would be relevant in this question also. So yeah, if we move on to the next one, given the incredibly fast and unpredictable industry, how do we CS students stay relevant and abolish the fear of being replaced by AI? In a nutshell, how do we become future proof? Yeah, this is a very valid concern. Uh, not even undergraduates, people in the industries also have, because it gets scary sometimes when we see AI doing things that we certainly didn't expect it to do. Mm, so I wouldn't say it's not going to impact. Like I have been saying, like adaptation is the key. Adaptation is what's going to save you. But you have to realize adaptation is hard in these cases like this, and sometimes you it wouldn't be obvious like how to adapt in certain scenarios. So I am not going to sugarcoat it. It might become a hard platform or like a hard field to like be relevant in, especially with the advancement in AI. But if you think you have the courage and the attitude to learn, uh, you are going to like get some relevancy at any time. As I have mentioned, even in that meme, there's always going to be, at least for the moment, someone that needs to like drive the tractor there. So even if it looks like AI will be the end of like all logical thinking and logical work, uh, just have the I guess the safety net or like the mindset that uh, there's always going to be the next thing. There's always going to be something different that people will pivot to, because like uh, the previous revolutions in the technical space might have felt like this, like what we feel right now. We just don't know about it. But humans as a species prevailed, and like engineers and uh, technical people in the industries, they prevailed. So it's just the hope and the assurance that and the uh, attitude we have towards us and towards learning and thriving in a field that should help us prevail also in the same way that previous predecessors prevailed. Because uh, it's it would sound like a lot of hopeful jargon, but it is actually what it is from what we can see at this point. But I'm going to say like at the same time, it's not going to like make everything obsolete like really fast, hopefully, because you will have the time to adapt. You just have to be really mindful and be more active in learning than you had to be maybe 10 years back. That's one thing I would give as an advice. Like, try to be more active in learning than what you had to be 10 years back. Because uh, if it's a hard time that's coming, we need hard work to like stay relevant and like thrive in those spaces. So yeah, that's something I can give as a input on that. Next one, learning building with AI. How do you go about learning? How do you know that you learned enough? Say that you want to build something, but you lack the knowledge. How would go about to build it? Okay. How do you go about learning? I'll simplify it to the point that whatever you are trying to do, whatever you want to know, you need to like have the understanding to a level that you can break it down and explain it. That's always like an abstract way that even for a long time people have been like mentioning learning. This is what learning feels like. But how do you know that you learned enough? This might sound cheesy, but uh, pretty much it's not like never enough. I'm not saying in a way like be like an obsessive learner that like doesn't sleep, doesn't have fun. It's not like that. I'm saying like you always need to know. There's no person that like knows 100% uh, on any field, and that that understanding itself is what's going to propel your learning, because it's like a graph where you are slowly building confidence, and at a certain knowledge level you'll be very high confident thinking you know a lot about the space. But it's always after you understand that compared to what you have learned, there's much more to learn, and it's never going to end. That's where you find the peace in like picking out what's interests you, and always uh, learning something new every day. Because if you think of it in one way, it might sound kind of depressing that you are not able to like learn everything in a lifetime. But think of it in the other way, you are never going to get bored of like learning new things if there's endless things to learn. So just try to make most of that. And the last part, say that you want to build something but you lack the knowledge. How you to go about to building? So there's a fine line there because there's so much knowledge that you can gather before like starting to work on something. But at the same time, it's always better to start early and fail and learn through that failing process also. So once you sort of like get that drive to like I want to start coding on this, try to do it like especially if you're doing like hobby projects. But I'd say it depends on the scenario because like if you're doing like academic work, it's better to like go through the theory thoroughly first and try to understand as much as possible, then move on to the practical part. But if it's like a hobby project, just to keep the motivation and drive going, try to jump straight to building as soon as you can. And if it's in the industry, it's a fine balance because as always, gathering the requirements, gathering the knowledge that you need before moving on to the implementation phase is always the must have in the industry. So I hope I answered most of those questions.
All right. Thank you for all your thoughtful questions. I will extend a huge thank you to our speaker for his insightful answers. We hope this discussion provided valuable clarity on AI integration in competitive programming. On behalf of the IEEE Computer Society and all participants, we extend our heartfelt gratitude to our speaker, Mr. Naveen Pemaratne, for sharing his expertise and providing invaluable guidance today. Your insights are truly inspiring. Before we wrap up, we'd like to extend our heartfelt thanks to our amazing partners whose support made CodeRally 6.0 possible.
Artificial intelligence will impact all of our lives and how we work. IFS.ai is industrial AI. It's the thread of intelligence flowing through your business in a world where data is everywhere and informs the lifeblood of your company. The thread that powers decisions made by humans or machines. The thread that revolutionizes your operations, optimizing your people, assets, and service. The thread that enables the world's most progressive organizations to contextualize intelligence, simulate outcomes, automate production, and drive innovation across your business at pace, safely. We're going beyond co-pilots. We're powering intelligent business. IFS.ai, industrial AI that enables your business to thrive and grow.
That in my zone. I had to get out alone and figure it out on my own. And I know what I really want now. Can't stop me, can't break me. But don't kill me, don't make me. Shoot for the stars, no safety. And now I see clear in HD. Gotta go hard, gotta go hard. I ain't got time to waste. I ain't got time. I gotta go high, gotta go high. I gotta elevate, I gotta elevate. They wanna fight, they wanna fight. I'm just gonna let them hate. I'm just gonna let them hate. I gotta go high, gotta go high. I gotta elevate, I gotta elevate. You gotta choose a side, you gotta choose a side. You gotta pick, you gotta do what's right. Or you gonna lose the fight. You gotta choose a side, you gotta choose a side. You gotta go Ay, you get the bag and fumble it, I get the bag and flip it and tumble it. Straight off the lot, 300 cash, and the car came with a blunt in it. Lil' mama a thot, and she got ass, that she gon' fuck up a bag. Pull up to the spot, living too fast, dropping the dip in the stash. In Italy, got two foreign hoes, they DM me. Draw the top, when it's cold, but you feel the heat. Be real with me, keep it 100, just be real with me.
When a company takes care of its employees, employees always take care of the company in return. This company values honesty and always thinks from an employee's perspective. All the good things that we've done so far has been a suggestion from an employee. So one of the things that makes CalC a great place to work is we respect all our employees, irrespective of the designation. So if you take Danushka, who's our CTO, who has been with us from the inception, or else an intern who has just joined CalC, the ideas, opinions, suggestions would be given the same value. And I think that's one of the reasons why people always come back to CalC.
Elephant House Wonder Ekka Be the Wonder.
දවසම පිනවන වෙනම ලෝකයක්. Pearl Bay බණ්ඩාරගම ඩේවිඩ් පීරිස් සමුව්‍යාපාරයට අනුබද්ධ ආයතනයකි.
Artificial intelligence will impact all of our lives. And
First, our strategic partner, IFS. Thank you for your continuous encouragement and powering innovation in our community. To our bronze partner, DMS Software Technologies. Your contribution helps us to take CodeRally 6.0 to new heights. To our associate partner, Cicada Private Ltd, we truly appreciate your support in helping us drive this initiative forward. A big thank you for Acceler, our supportive partner, for inspiring us to push boundaries. Our hackathon partner, Kelsey, thank you for championing creativity and the spirit of competition. Thank you for Pearl Bay, our gift partner, for bringing extra excitement to our event. Shout out to Pepsi, our original beverage partner, for keeping everyone refreshed and energized. Thank you to Wonder, our official snack partner, for making sure no one codes on an empty stomach. And last but not least, Lumora Studios, our official media coverage partner. We appreciate you capturing all the memories here. We are grateful for your continued support and encouragement. Before we conclude, we'd love to capture a group photo to remember this amazing session. It'll only take a moment. Could everyone please turn on your cameras for a quick snapshot? All right. Thank you once again for joining us for Workshop 2 of CodeRally 6.0. We hope you found today's discussions insightful and inspiring. Your enthusiasm and engagement make this workshop an impactful experience. Also, don't forget Selection Week begins on 4th of August. We'll give you the chance to put your skills to test and advance further in the CodeRally journey. Keep an eye on our official channels for more details and announcements. Please make sure to follow us for updates and stay connected with our community. We look forward to seeing you in upcoming workshops. Until then, stay curious, stay ambitious, and keep building your future. Thank you.